Hi, welcome everyone. Today we are gonna discuss about the chapter 3, which is forces and laws of motion. At the first we will talk about the force, then we will discuss about the laws of motion. What is the force? I will explain it in the next page with the definition, but I think everyone knows what is the force, because in our daily life, in everywhere we are using a force, like while opening door, while walking, or we can give a lot of example. As you see on this picture, when they are exhibiting, they are applying force to each other to beat each other. And what else? We can give a lot of example. Or car industry, they are using force. How? As you know, when you get in the car, when you start your motion, there are two important points or important properties for the cars. What are these? One of it torque, the second one is horsepower. Maybe you heard about the horsepower. It is the power of the engine, and the torque, it is the turning effect of the force, and it helps the movement of the car. And the torque is related with the next year subject, so you will study it in the grade 12. But here we will talk about the force, so this chapter will assist you understand next year's chapter in grade 12. So in everywhere in our daily life we can see the force, simply we can say. And let's talk about the definition of the force. Definition of the force. First of all, we will talk about the 3.1, change in motion. And here there are many definitions of the force. The one of is this, you might know for the examination: an action exerted. This word is important: an action exerted on an object which may change the object state. So that means force can change object state, rest, or motion. This is important. In the next page we are going to talk about this. But here there is a word which is exerted. It doesn't mention, instead of this one, it can say applied. But this is mentioned what? Exerted. It has mean, because there are types of force we will discuss about. If we say applied, that means we might observe contact between two objects. So this is the definition of the force, and force can cause acceleration. We will discuss, keep this one in your mind. We will discuss about this in the another sections. Here there is a pictures, three pictures, first, second, and the third pictures. These pictures from your book. And as you see at the first, the girl throw the ball, and at the second, the guy hold the ball, we can say. And at the third picture, the guy hit the ball with the beam. And let's go to the next page. There is some important point you might know. These questions can be fill in the blanks in your examination. First of all, force can cause start moving. If the object is not moving, like at the first picture, the girl was holding a ball and then she started to throw it, and she applied the force on it and she threw it. So this ball starts moving. Let me change the color of the marker. This ball starts moving, and then force can cause object stop moving. So when she throw this ball, the another guy, you know this game, another guy gonna hold it and stop its motion. So here, as you see, the guy stopping moving ball. so the force can stop moving. And force causing also change its direction of the motion. So in the third picture, when the guy hits the ball, it goes in any other direction. So when the guy apply the force on it, the ball gonna go in any other direction, we can say. And also force can change the size or shape. For example, if you drink any soft drink, and then when it's empty, when you finish it, when you compress its can, you can change its size or its shape. Or the simplest example, if you are holding a paper, A4 paper, if you tear it, that means you change its shape and the size. So this is another example we can say. So force can cause those things. You should keep in your mind. Let's go to another page and let's discuss about the unit of the force. And it's written here on the screen because we are referring to SI unit system. So according to SI unit system, unit of the force is Newton. And here the Newton is the name of the guy, which is you are seeing on the screen, and the picture of the guy, which is Sir Isaac Newton. He discovered these rules almost more than 200 years ago. So now we are discussing about it. But even today we are applying some of his rules in our daily life. In the another part of the chapters, I will explain those applications. So you should keep in your mind, unit of the force is Newton, and Newton represented by the N, capital N, that is important. Force is not represented by with N. Unit of the force, which is Newton represented by capital N. Keep it in your mind. In the next page, force can act through the contact or at a distance. I told you they choose the word in the definition of the force exert, not the applied. Here is the point I cannot tell you. Now, according to your book, there are two types of force we can say now. Two types of force. One is the contact force, the other one is the field force. We are going to talk about them. Contact force, we can understand from its name. It is very simple and easy to understand. To see this force, we have to see physical contact in our action. For example, here there is a picture, the one guy in the car. Maybe you have seen this picture in your daily life a lot of times. I have seen a couple of times in this month. So another guy applying the force to the car. So here at this point is their contact point. When they contact, the guy applied the force. So with this force, the car starts moving slightly, we can say. So in this case, we have a contact. So we call that contact force. Now we are going to talk about the field force. Maybe you know the definition of the field, and now you know the force. So this is the second one, which is field force. This force applies one object to another object, but in this case there is no any physical contact. For example, in this picture, when you look at it, let's say this is the Earth and this is the Moon. So Earth actually applying the force to the Moon. This is called what? Gravitational force, we can say. And in our daily life, commonly everyone knows that magnets magnet. And as you know, like poles of the magnet repel each other, unlike poles of the magnet attract each other. So this attraction and repulsion doesn't happen with the contact. If two magnets close to each other, like this one, if two magnets close to each other, they're gonna repel each other because their north faces looking at each other. And here, in this case, in the second case, we can say here, north and the south poles facing each other. So if they are enough close to each other, both magnets can attract each other. But this force will happen without any contact. We can say it will happen from a distance. If it is from a distance, we name it field force. Another example, electric charge. Electric charge, as you know, we have two types of charge, positive and the negative charge. And as you know, like charge repel each other and unlike charge attract each other. So here we call that electric field force. So here we have a positive and negative charge. So from a distance, they're gonna attract each other. And in this case, here we have a two like charge, positive and positive. They're gonna repel each other. In this case, they are not touching each other. However, they apply the force each other from a distance and without physical contact. In the previous chapter, we discussed about the vectors, vectorial quantity, and the scalar quantities. Force is a vector. What does it mean? As you know, it has magnitude and direction. So every vector represented by an arrow. So also force represented by an arrow. So here, this is our arrow, which indicates our force. And if any force has an angle, as we discussed in the previous chapter, if it has an angle, it has component, x component and the y component. So fx equal, it is at the adjacent cosine theta times f, and fy equal sine theta times f, we can say. So if force makes an angle with an horizontal, we have to separate it into component in the case of we need. Otherwise, you don't need to separate it. So here, you have to know force is a vector, it is a vectorial quantity. So if we know the force, we know the magnitude, and we know the direction of the force. And we can see it, we can observe it by an arrow. Keep it in your mind. And free body diagram. What is the free body diagram? Here you are looking at the two different pictures. And what does it mean? I will explain to you. But simply I can tell you free body diagram. What is the free body diagram? Simply we can say drawing all the force acting on an object. At the picture A, if the car hits to the wall, for example, it's gonna apply the force, the car can apply the force to the wall, and force itself, it has weight, so because of its weight, it's applying force to the downward, and the earth apply the force on it. And then, also when the car hits the wall can apply the force on it in the opposite direction, and because of the weight of the car, it's gonna apply the force to the earth, and the earth can apply the force on it. But simply we can say for the free body diagram, drawing all the force acting on an object. in the next page I will explain it to you with a picture. It will be more understandable, I think. For example, here, drawing free body diagram. Here, as you see in this picture, the father pulling his son, whatever else, it doesn't matter, as you see on the icy place, on the ice cap. And here on the ice we can ignore the what? Friction. We can ignore the friction for now. Another part of this chapter we will discuss about the friction, but now we are not calculating it. Here, what kind of force acting? This one. The father or someone pulling it with a string. So here there is a force. We can say that force of pull, force of string, it doesn't matter what we name it. And this object has mass and it has weight. Because of the weight, it's applying force to downward. We call that F. Here it's called F earth. And earth also, to balance its position, applying a force in an upward, which means in opposite direction. I draw it a bit longer to indicate it's better. We call that F ground. So drawing all this force, we called free body diagram. Simply, I will draw it here one more time. Let's draw this object. This is the force which is applied. This is the force of the weight. And this is the force of the reaction of the earth. So this is our free body diagram. So we draw all the force acting on an object. This is the weight, and this is the force applied by the guy, and this is the normal contact force. And normal contact force in another part of the chapter we are gonna discuss.